Hello everyone. Today we are going to discuss electrostatics topic, that is system of charges in equilibrium. Generally, what is equilibrium? If you question yourself, equilibrium stands for a balanced condition. Okay, if the forces are being balanced so that net force equals to 0, then it is going to be translational equilibrium. If net torque also 0, it is going to be rotational equilibrium. If translational as well as rotational equilibrium is there, then it is going to be mechanical equilibrium. Okay, so here we are considering electrostatics in that system of charges in equilibrium. So system of charges means there will be some number of charges, maybe 4 charges, 5 charges, 3 or 2 charges also. Okay, so how to find whether they are in system, whether they are in equilibrium or not. Okay, if the system is in equilibrium, as I told you already, that is net force acting on the system 0 and also net torque acting on the system 0. Okay, so let us see whether we are able to apply that concept to this particular problem or not. Okay, so just for the sake of simplicity, I am considering just 3 charges. Okay, so consider, say, let it be plus q charge and here another plus q charge. Okay, and both are separated by a distance d meters, small d, which is fixed. Now where we have to place the third charge, say the third charge is small q. Third charge that we are going to place is small q. This small q, at what location we have to place, and also what amount of charge we have to keep, and also what nature. Okay, generally here to find the location they'll ask, okay, to find the location of the charge and to find the magnitude and nature of the charge. Magnitude and nature of the charge. Okay, so to find the location of the charge, if you want to find, okay, it's very simple. Equate the net force acting on the third charge to 0. Okay, to find the location of the charge, here itself I am writing, equate the net force acting on the third charge to 0. Okay, this equation will give you the location of the third charge. Okay, to find the magnitude and nature of the third charge, equate net force acting on any one of the charges. Okay, that is any one of the given charges to 0. That means what? If you want to find the location of the charge, then location of third charge where you want to keep, okay, that is what? That is, you have to equate net force acting on the third charge to be 0. If you want to find the magnitude and nature of the third charge, then equate the net force acting on any one of the given charges to 0. So that we are going to discuss actually. Okay, so assume we have placed at a distance x meters from the first charge, let it be first charge and second charge. At a distance x meters, we have placed a small q charge over here. Then due to the plus q and due to the first charge and second charge, there will be 2 forces acting on it, but the sum of those 2 forces must be equal to 0. That is what actually equilibrium. Okay, so due to the first charge, the force acting on this will be k capital Q into small q divided by x square. This is x distance. And due to the second charge, the force acting on the same charge is going to be k capital Q into small q divided by this distance, d minus x. Okay, so d minus x whole square. The sum of these forces must be equals to 0. Why they are 0? Because that is a definition of system of charges in equilibrium. Okay, condition. If you equate, definitely you will get k capital Q small q, to that side it will be 0, and it will come x square equals to d minus x whole square. Then we can say x equals to d minus x. Then we can say x equals to d by 2. Right? That means we need to place the third charge at midpoint of the line joining the 2 charges. Okay, so we found that. Next, if you want to find the magnitude of this this small q, or if you want to find the nature of the small q, you should equate the force acting on any one of the given charges to 0. Okay, so let us consider force acting on the second charge, this one. So due to the first charge, the force acting on it will be k capital Q into capital Q by d square, and due to this small q, the force will be k capital Q into small q divided by, we have already found this one x as d by 2, so we can substitute there. You substitute, you will get d by 2 square. Of course, sum of these two forces again must be equals to 0. Why they are 0? Again the same, the condition for equilibrium. Okay, if you solve this, trust me, you will get the small q will be equals to, k capital Q by d square gone to 0, and small q is going to be minus q by 4. The minus indicates that you have to place that negative of the plus q by 4. Okay, that minus indicates, unlike charge it is. I hope you got it. And the rule I will tell you again. To find the location of unknown charge, you should equate the net force acting on the unknown charge to be 0. To find the nature and magnitude of the unknown charge, we should equate the net force acting on any one of the known charges to 0. Okay, this is the system of charges in equilibrium, and this can be a shortcut. Thank you. Whenever system of charges is given, there may be n number of charges. Okay, all those must be point charges, and they may be like charges or unlike charges. I mean identical, unidentical. Okay, identical in the sense all the charges having same magnitude and same nature. Okay, and unidentical stands for they may have different magnitude and different nature. For example, there are four charges given, and 4 charges are equal to plus q each, and they are placed at the 4 corners of a square of side A. Then how much charge should be placed at the center of the square, so that total system is in the equilibrium. Okay, so that we are going to discuss actually. General, just now I said the problem here this way, like this one. If the capital Q here and everywhere, like 4 capital Q's are placed, and the side of this square is small a, whatever the charge you keep here, the net force acting on the center charge must be 0, because this point is symmetric about all the charges, and due to each and every charge there will be 4 different forces on this center charge, and 4 forces, they will cancel each other. For example, if you consider a plus 1 coulomb charge over here, then due to this first charge there will be a force this way with magnitude F, let it be. Due to the second charge, the force will be this way, and again same magnitude it will be because same distance. Okay, and due to third, the force will be this way, again F Newton, and due to the fourth, the force will be in this direction, again F. So what is the net force acting on this is going to be 0, because these two will get cancel each other because they are in opposite direction, and these two also will get cancel each other because of the reason same, again they are in opposite direction. Okay, so net force acting on the center charge is going to be 0. Okay, but what is the force acting on different, like other charges? Will it be 0 or not? Here it is not 0, because of this plus 1 coulomb force, the force acting on each and every, the force acting on remaining charges is not equal to 0. Or let me repeat the statement again. Okay, due to the plus 1 coulomb charge which we placed here, the net force acting on any other charge is not equal to 0, because the plus 1 coulomb is not sufficient to balance the system. Okay, to balance a system, there should be some charge placed, small q, that we need to find actually. Okay, so that is what actually system of charges in equilibrium. System of charges in equilibrium. Right. So what is this equilibrium? It is net force acting on the system 0, and also net torque acting on the system 0. Okay, that means force 0, torque 0. Force 0 on which charge? Force 0, remember on each and every charge the net force must be 0. Okay, torque 0 on which charge torque 0, again here also on each and every charge torque must be 0. Then only the system is said to be in the equilibrium, otherwise not. Okay, so we are going to discuss the situation here. Okay, and my point that you should remember, whatever the charge you keep here at the center of the square, on that charge only the net force 0. On the other charges the net force may or may not be 0. If the other charges also experiencing net force 0, then the system is said to be in equilibrium, otherwise it is not. Okay.